Hi, this is Brian Kemp for Flex. We're here today at Wearable Technologies with Dr. Joan Vrtis, the CTO for Multek. Hi, Joan.
Hi.
So tell us a little bit about what Multek does and kind of some of the real unique products and technologies that you're involved in.
So Multek is the printed circuit company. We're a wholly owned subsidiary of Flex, and we do really cool stuff. Basically everything starts with a circuit, and if you look at what Flex does, it's all electronics essentially. And so having somebody like a Multek as part of the whole integration within Flex really gives us a very nice position. From my standpoint as the CTO, the nice thing about being with Flex is I get to see everything that goes on in all the segments, because every one of the segments needs something electrical. And so we'll do things like today, we have wearable technology. And so you have multiple things in wearable technology. You have a flexible circuit that may go in a wristband, and then how do you put that same type of circuit into clothing or a hat or shoes? So, you have to look at not only the flexible circuit, but do we need to do something where it's a rigid flex? It's something where maybe you need a wireless component on it, Bluetooth, etc., where you have that rigidity that's required, and also more functionality. And then we also do, simple things like where it's print electronics. Print electronics for us is becoming more and more a focus area for a lot of the customers' needs. And the nice thing about the print electronics side is because it's at infancy, it's been around for a little while, but from the standpoint of a wearable technology and what it can do, it provides even more of a breadth in the electronic side of a circuit. And so we have a big activity going on with that with our Northfield site. Northfield is probably one of the leaders in print electronics. They've been doing it a long time, and now it's really coming of its own. They can use the technology that they've had for years and make some tweaks to it and really start to ramp it. And so I think between the standard flex, a rigid flex, and print electronics, we have the entire suite that's required to have anything talk to each other that's smart and connected.
Nice. Now, print electronics, what are some sort of applications or end products that you would use then?
When you start looking at print electronics, you can look at things like sensors, resistors, where you can actually do that fabrication with a ink system. So it's an additive, and I won't get into all the details of the difference, but it's a different type of process where you can draw what you want exactly on the base system. And so when you start looking at sensors is a perfect place to go. If you were to do a resistor where you want to tune it in, you can use a different type of inks. We can do things where we draw it a little bit differently, tighter line spaces, which is common for us as far as tuning things in. The other nice thing about having these new technologies in print electronics is as we move forward in this space, print electronics allows you to just draw where you want it. So you put the circuit where you want it by doing some sort of an additive drawing process. It's like when you write on paper. When you write on paper, you're taking your ink, you have a piece of paper, and you write on it exactly where you want your name. You can do that with print electronics. You write where it's at. And so it adds benefits. I'm making it sound simple. It's not that simple, okay? But it gives you the concept of the difference and the breadth of what this can lead us into. And so when you start looking at what we're doing in the wearable technology space, and you want to put a sensor system maybe in a sleeve, it's very nice if you could just draw that sensor and you laminate it in the sleeve, and you could put a component on top and it talks to your phone or whatever you want as far as the metric or sensor. You know what I mean?
So
it makes it a lot easier.
Fit everything in particular boxes, it really gives you that freedom to just be much more creative and really do what the product needs it to do.
Right, and then what we do is we can ramp it into high volume and just make miles and miles of it. So there's a lot to this that's not just a matter of making some simple prototypes. Is you can make the prototype and then you can lead that into a high volume with the same type of solution. It's perfect. I mean, it gives us a lot of a broader footprint for electronics.
So it really scales very easily.
Yes.
I know, Flex talks a lot about our sketch-to-scale solutions. Any particular products or stuff that you've been involved in where you've seen that really kind of that vision come to life?
It's interesting. Sketch to Scale is a nice initiative for the whole Flex footprint. when you look at what we've been doing in circuitry for a while, you have customers that come to you and they're looking for a solution. And some of the aspects of things that we get into is that we have to almost be a sketch to scale group, because people come to you and they have a different schematic, you know, the electrical requirements of this. It's not just a cookie cutter where you go to the store and you can buy a package of Oreos, which I like. But so it's one of these things where for the sketch to scale, it starts with, for me, it always starts with the circuit. And then when we do the development around the circuit, we always have, what is the end game going to be? What's the application this is going to go into? The reason I ask that, if it's something that's going to be a wearable device or a wearable product, it's going to move. And unlike in your cell phone, that board, or that, if you look at even the camera module, which has a flex circuit, that doesn't move once it's put in a phone. You drop it, maybe it moves, but it doesn't move like wearing a shirt where you take it on and off every day, or some sort of a band, activity band where you're taking it on and off every day, a shoe where you're going to run and you're going to step in, you know, maybe when you're running, it's raining out and you worry about sweat. And so that whole application space is different than what we've had to deal with before. So when you say sketch to scale, it's a matter of not only the electronics piece of it, but what's the application? Because that brings in that entire ecosystem of understanding before we can actually get a circuit that we know is going to function in high volume.
That makes sense. And then again, having something much more durable and much more designed for the real world. I mean, there's a lot of great products that are going to be set in a particular location and used in that location. But when you're putting lights onto a shirt or something like that, you need to throw that in the wash. So it has to still work.
Yeah, and I did this analogy the other day when we had a customer and they're like, oh, we want to be able to make this washable. And I said, okay, well, you know, electronics, you know, we usually don't throw that in a washing machine. Well, why not? I said, do you throw your phone in water and expect it to work? It's the same type of thing. So we have to think about, how do you do waterproofing versus water resistance? You know, how do we do this in high volume manufacturing? And then it's not only just a matter of the ingress of water, it's all the other things that surround it. So I may be able to make the circuit and put all that waterproofing around it, but it still has to go through the rest of manufacturing. So working with the flex partners, whether it's CTG or HRS or who it needs to be in the segment, the nice thing about having Multek as part of that whole vertical chain is we all talk. And I know when I build this, if I have to put a TPU around it, we understand what that means. How does it get assembled? How does it get moved? How do they test it at the end? And so that's why the nice partnerships within the segments are great for Multek, because we get to see everything that everybody's trying to do, and we actually can help them also. So I think it's a good partnership.
One last question. So kind of as you're seeing where technology is going, you know, over the next year or two, what really excites you? What really has kind of been surprising in terms of use cases, or just kind of where things are shifting to?
So I do a lot of things. It's not just wearable technology. So Multek is very broad. We're working on 5G right now. And it's interesting, 5G, everybody's like, oh, I got a 4G phone. But think about where this is going. 5G, if you see what's going on right now, people like to stream. So they're streaming videos, they're streaming information. As we start going, we need more and more, faster and faster and faster. This 5G, this infrastructure is going to be key. And so as we move that route, I see where that to me is going to enable everything else underneath it. Once you have that 5G out there, you're going to need a new 5G phone, because your 4G phone is not going to do what you want it to do. You have autonomous driving now because it allows for minimizing any latency that goes on. So anything that has to do with sensing and it has to go somewhere to the cloud is going to have some sort of 5G component. And so for me, 5G, making sure that I'm on top of what needs to happen in 5G is really key. And it comes down to materials. It comes down to the roughness of the copper, because I move electrons. Nobody thinks of that. I think electrons. What does that have to do with the rest of the world? It's how you're going to connect. You'll never know that. You'll know it now because I just said it, but you never would think about it. You just want to use your phone. You just want to get in your car. You just want to stream your stuff. You don't want to think about it. So for me, the exciting part is the 5G and then everything flushes underneath it. So that's
Look
where I
forward
say,
to that.
yeah, thanks.
Great, this is Brian Kemp for Flex, here with Dr. Joan Vrtis. Have a good day.
Thank you.